Question number 106. What occupies the space between the cell wall and the shrunken protoplast in a plasmolysed cell? First option, hypotonic solution. Second, hypertonic solution. Third, isotonic solution. Fourth, pure water. So when a cell is plasmolysed, it means the water has come out, and when this water comes out, when the cell is present in the hypertonic solution. So let us understand this with the help of this simple diagram. If this is the solution and a plant cell is present inside this, then water moves from its higher to lower water potential. If the cell has more water as compared to solution, water will move out, and the space between the cell wall and the shrunken protoplast will be occupied by the hypertonic solution. So the correct answer for the given question is option number 2. Let's move to the next question. Question number 107. Which of the following is not included in the Arnon's criteria to determine essentiality of elements? First option, the element must be absolutely necessary for supporting normal growth and reproduction of plants. Second, the element must be easily absorbed by the plant. Third, the element must be directly involved in the metabolism of the plant. And fourth, the requirement of the element must be specific and not replaceable by another element. So you have to tell the statement which was not included in Arnon's criteria to determine the essentiality of elements. See one by one. The first is the element must be absolutely necessary for supporting the normal growth and reproduction of plants. Yes, the element which is considering as the essential should support the normal growth as well as for the vegetative and the sexual reproduction of plants. So this is correct. Third one, the element must be directly involved in the metabolism of the plant. It is also correct that it should involved in the metabolism of the plant. Fourth, the requirement of the element must be specific. Yes, the requirement of that element must be specific, and the element should not be replaceable by another element. So this is also correct. See the second option that says the element must be easily absorbed by the plant. No, this was not the criteria. So the correct option for the given question is option number 2. Let's move to the next question. Question number 108. Select the bacterium which is free-living aerobic nitrogen fixer. First option, Thiobacillus. Second, Begonia. Third, Rhodosparallum. Fourth, Rhizobium. You have to choose the bacterium which is free-living and aerobic nitrogen fixer. Rhizobium, it's a symbiotic nitrogen fixer. So this option is ruled out. Rhodosparallum is anaerobic nitrogen fixer. So this option is also ruled out. Thiobacillus involves in denitrification. So this option is also ruled out. What about the Begonia? Yes, it is aerobic and free-living nitrogen fixer. So the correct option for the given question is option number 2. Let's move to the next question. Question number 109. Phosphoenol pyruvate PEP is the primary CO2 acceptor in the cells of first option epidermis, second mesophyll, third bundle sheath, fourth phloem. PEP or the phosphoenol pyruvate is the primary CO2 acceptor in the mesophyll cells of the C4 plants. So the correct option for the given question is option number 2. What about the bundle sheath cells? Yes, in C4 plants bundle sheath cells are also present, but there the primary acceptor is the RUBP, not the PEP. Let's move to the next question. Question number 110. How many ATP and NADPH molecules respectively are required to synthesize one molecule of glucose through the Calvin cycle? First option 12-18, second 30-12, third 18 and 12, fourth 18 and 30. The Calvin cycle is the cycle to fix the CO2 in plants. Now, there are 3 steps in the Calvin cycle known as carboxylation, reduction and the regeneration of RUBP. For one CO2 molecule to be fixed through Calvin cycle, the number of ATP molecules required are 3 and the number of NADPH molecules are 2. If we want to fix 6 CO2 molecules to generate the glucose, as glucose is a 6 carbon molecule, so for 6 CO2 molecules to be fixed, 6 into 3, 18 ATP molecules, and 6 into 2, 12 NADPH molecules. So the correct option for the given question is option number 3. Let's move to the next question.